Guys, happy Monday. Hope all is going well. Again, we are going to continue our Unit 16 on other functions. So far we've learned the big three: linear, exponential, and quadratic. In the next two lessons, we're going to be introducing you to four new functions. And the first two in this particular lesson are going to be absolute value and square root functions. Absolute value and square root functions. All right, so to get us started as a do now, we are going to solve for x in each equation. These you know how to do, so that's why I call this a do now. Great time to pause the video and then press play after you've attempted these four problems. All right, go ahead and press pause, try them, and then hit play when you are ready. All right, so to solve the absolute value, we need to set both of these parts equal to the function, but one with a positive 9, and then the other one with a negative 9. That is really important for solving absolute value equations. So now if we go through the process of both of these equations, the left side is going to be 2x equals 8. Giving us a value of x equals 4. On the right side, we're going to get 2x equals negative 10, giving us a value of negative 5. So our two values are x equals negative 4, or we could have x equals negative 5. So x equals 4 or x equals negative 5. All right, moving on to the next one. We are going to do number 2. Now remember, in this one, it's really important that you isolate the absolute value. You need to isolate the absolute value first. So the first thing I'm going to do is get rid of the 2. So I'm going to bring down the 3 with the x minus 4. And I am going to set that equal to 6. Now, I'm going to divide out the 3, so I'm going to get x minus 4 is equal to 2 in the absolute value, of course. And once we have isolated the absolute value, then and only then do we create our two equations, setting it equal to 2, and we know absolute value makes everything positive, so to account for that, we are going to set it equal to negative 2 and see what we end up getting. So this answer is going to be x equals 6, and this answer is going to be x equals 2. So we have two values of 6 or 2. Now just keep in mind, always go back and take these values of x and plug them back in to the original x, just to double check that it does work. That is really, really advantageous to do that always. Get in that habit. All right, going on to number 3. Let's go to this equation. Now what makes this different is that there's algebra on both sides of the equal sign. There's unknown values of x. So what we do, since the absolute value is already isolated, we just simply solve the first one as is. And for the second one, it's going to be 4x minus 7 equals. Now, just like in the other ones, we negate this. We are going to negate this. So the big question is, how do I negate x plus 2? Well, distribute a negative 1, and it's negative x minus 2. Now I'm going to go through and solve both of these. This is going to be 3x equals 9. Again, I'm just literally moving the x to the left side, the negative 7 to the right side, and that produces an answer of x equals 3. Now I just want to double check that real quick. 4 times 3 is 12. 12 minus 7 is 5. So I would get a 5 on the left side and a 5 on the right side. That checks out nicely. Always take the time to check. This one's going to give us 5x equals 5. and we're going to get a value of x equals 1. I'm going to check it off, especially when there's algebra on both sides. When there's algebra on both sides, you really want to check your answers. So if I plug in 1 here, on the left side, I'm going to get 4 minus 7 is negative 3, but the absolute value of negative 3 is 3. And on the right side, I'm going to get 1 plus 2, which is also 3. That also checks out. So I actually have two answers. X could be 3 or x could be 1. Awesome. Let's do our last question in this do now warm-up, and then we're going to graph a few functions today. I'm going to divide out the negative 2, and I get absolute value of x equals negative 6. Now, immediately I look at that and go, okay, if this absolute value makes everything positive, you guys know that absolute value makes positive. So the big question is, can absolute value ever be negative? The answer is no. So here we have an answer of no solution. So I hope you got that. No solution. All right, very good. So what we're going to do next is we are going to move on to graphing absolute value functions. First thing I want you to do is get out your calculator, and you are going to follow this nice set of instructions. You're going to hit math, number, and then go to number 1, and it's abs. That stands for absolute value. Go into your y equals and type in the function f of x equals the absolute value of x. So again, I'll do that one more time. In your y equals, again, we are in y equals. Go to your y equals. And to get this symbol, the absolute value symbol, you do math, go to number, and do number 1 abs. That's going to open up a nice set of absolute value symbols for you. And then you could put in the x that we use for every single function. Do me a favor and just fill in this table of values. I'm going to let you know right now, though, you do not need to even go to your calculator for this. This is quite easy because the absolute value of all these numbers is really kind of straightforward. Absolute value of negative 3 is 3. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. 2, and 3. So we get this nice set of outputs that goes with our function. So what we want to do is we want to come over here on the graph and we want to plot these points. So let's take out a pen. You're also going to need a ruler. If you don't have a ruler, pause the video, go get a ruler, and we're going to plot these points together and create a nice function. So we have negative 3, comma 3. So our first point is going to go negative 3, 3 right there, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. Now, what's the first thing you notice about this function? It almost looks like a parabola. Actually, it takes on the shape of a V. As where a parabola has a kind of curve to it, this is linear on both sides. So this is actually linear on this side, and then it is also linear on this side. So you want to kind of just get through those points the best you can. Again, with a ruler, you can make it look really nice. It takes on the shape of a V. And as always, we want to label. So we are going to label this f of x equals the absolute value of x. And that function is done. So what's the first thing we learned today in this new lesson? Is that absolute value functions look like a V. That's really important. What you'll also notice is, like a parabola, they actually hit a minimum point. So they have a vertex. They have a lowest point, in other words. So the minimum value here, and when I say minimum value, I'm asking you for the y value. When I say minimum value, I want the y value. So the minimum value here is 0. That's the lowest this function goes. the domain. I can take the absolute value of any number in the world, so our domain is going to be all real numbers, negative infinity to positive infinity. And to state the range, now, here's where it gets a little different. The range is not all real numbers. The range is actually only greater than 0. So the range is y is greater than or equal to 0, or you could state it like this, 0 to infinity in interval notation. All right, and the last question here is, state the domain over which the function is increasing. State the function where it is increasing. Now, I want you to look along this graph. Now, let me change the color so you can kind of see this clearly. This function is decreasing, decreasing, decreasing until it hits a minimum. And then what does it start doing? It starts to increase, increase, increase. So this function is increasing to the right of 0. As soon as it hits 0, then it starts to increase. So it's increasing when x is greater than 0. We call this the parent function. So every type of function has what is called its parent function. It's basically the simplest function that will still satisfy the definition of that. So what we're going to do just for a minute is on the next page, we are going to look at different absolute value functions and how they change depending on different numbers and different placement of numbers. So first off, let's read the definition of absolute value together. Absolute value functions. One of the most recognized piecewise functions. When finding the range of an absolute value function, you have to first find the vertex. That's very important. The range, just like in parabolas and quadratics, it's related to the vertex. In the graph opens upwards, the range is greater than or equal to. It's going to be greater than or equal to the y-coordinate. If the graph opens downward, it's going to be less than or equal to the y-coordinate. And the average rate of change on either side is what we would call constant. The reason it is constant is because there's a straight line on either side. All right, so let's get into these examples. Here's what I would like you to do. Pause the video, take a few minutes, and attempt these 4 problems. So what you want to do is you want to create a table of values. You want to plot the points, and then draw the absolute value function. They should look like a V if you do it correctly. That's why you have to do it with a straight edge. And at the end, don't forget, please, please, please state the domain and the range. State the domain and the range of each function, and then this question will be done. Go ahead and pause that video, and I'm going to cast to the screen all of the solutions so you can check your work. All right, good. So I hope you had some time to do these. What I did is I went ahead and graphed all 4 of these using my calculator. I went to a table of values and I plotted these points. It is good practice to write down some of the points you used, but you can check your points with mine to see if you got it. Overall, you want to make sure that the V shape is in the correct location and whether it's facing up or down. What I did want to do with you, however, was I did want to answer the question about domain and range. Now, domain is going to be easy. Domain of any function, let's start off with A. Domain of any function is going to be all real numbers for these absolute value functions. So the domain is going to be negative infinity to infinity. Now what changes is the range. So the range is going to be a little bit trickier. So what I want to do is I want to zero in on this function, okay? What I want to do is zero in on the turning point. I need you to look at the turning point right here. Now, what is the smallest output you will see in this graph is 0. So that would mean that the range is from 0 to infinity. You may also write y is greater than or equal to 0 as well. Let's go ahead and find the domain and range for number 2. Again, absolute value functions, the domain will be all real numbers, so that makes our life very, very easy. So let's go ahead and write all real numbers for our domain. Make sure that is what you wrote as well. We're going to have negative infinity to positive infinity. And the range, again, what are we zeroing in on? What am I really interested in is that vertex point. Well, that lowest value is 3. So the range is going to be from 3 all the way to infinity. Or you could say y is greater than or equal to 3. Now let's go down to number 3. Again, making your life very, very easy. The domain is going to simply be all real numbers. We are going to go from negative infinity to positive infinity. The range, however, on these functions is not all real numbers. So we are going to zero in on that vertex point. The highest point, because this is a maximum, the highest point is negative 2. So that means it's going to go from negative infinity all the way to negative 2, and then it stops there. You can also say y is less than or equal to 2. And then for our last one over here, we are going to state that the domain is simply all real numbers. So the domain is negative infinity to infinity. And then we have our range, which is going to be based on this vertex point. And that looks like the highest point it is going to reach is 0. So we will say from negative infinity to 0 will be our highest point. Awesome. So now we're going to move into our second part of these notes, which is the square root functions. The square root function is also called a radical equation. A radical equation. So keep in mind, there are multiple types of radical equations. Today we're going to focus in on the square root. Square root radical equation is when the variable is in the square root symbol. The variable has to be in the square root symbol. Notice how this variable is not in the radical equation. This is just a normal equation. Subtract rad 3 and you get an answer. This is a little bit different. So what we're going to do is isolate the radical. Follow these steps. Isolate the radical. If the radical square root, in this note it is, we're going to square each side because squaring and square rooting are what we call what? Opposites. That's right. And then we're going to solve the equation. So let's jump into a few of these here. So focus in on number 1. What's the opposite of squaring a number? Square rooting, is squaring. So we are going to square both sides of the equation, and we get 5 squared is 25. So that's really, really easy. That's the answer to our first one. When I square the second one, I'm going to be left with x over 2. Remember, square root squared, these guys are what we call opposites. So they kind of undo each other, which is really convenient in a nice way. Then I have to square this side as well. Well, that's just 4. So x over 2 equals 4. You could skip this step if you wanted. Multiplying both sides by 2 gives me a value of 8. So our next answer is 8. Jumping on to number 3, and if you want to pause the video at any time and try these without me, that would be very, very awesome, and I encourage that. Okay, step 1, isolate the absolute the square root. So I'm going to move this 5, so the square root of 2x plus 4 is equal to 5. Now I'm going to square both sides. So I'm going to get 2x plus 4 equals 25. And I'm going to get 2x equals 21, and x is 10.5, or 10.5, we'll say. And lastly, what do we notice that's a little different is we have to square both sides because there's radicals on both sides. Well, this actually turns out to be a very easy question, because both the square roots and squares cancel each other out, we're going to then just simply move the 2x over, move that negative 4 over, and we are going to get x equals negative 2. Now, as always, you always go back and plug in. Always plug in. Especially when there's variables on both sides of your equal sign. But if you plug in a negative 2, you end up getting the square root of negative 10 on both sides, which is fine. Even though it's an imaginary number, it's still the value of negative 2 works. All right, so that is how you solve square root equations. Now we're going to do our last part of the lesson, and we are going to graph these things. So again, go to your y equals, fill in the table of values, and we are going to graph some points and see what these functions look like. So if I'm going to use 0, now you might say, why start with 0? Well, can we square root a negative and produce a real number? That's our question. The answer is no. That's an imaginary number. So let's start with 0, 1. Now, I'm going to skip 2. Why do you think I'm going to skip 2? Is because the square root of 2 is irrational. So I'm going to jump right to 4. And then I'm going to jump to 9. I'm going to try to keep what's under the radical a perfect square. If I can keep that a perfect square, then my life is much easier. Now, I'm not saying you can't put 2 under there. Of course you can, but we're trying to get some nice points to graph. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So what we're going to do is we're going to come over and we're going to graph those points. We're going to graph those points. So take out your pen or pencil and begin graphing these points. So we have 0, 0, we have 1, 1, we have 4, 2, and then we have 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 3. That gives us a point there. Now, this is not a straight line, so there's no ruler needed, but you do have to carefully bend through these points. And then you get your square root equation. And we are going to label it just as we always would. F of x equals the square root of x. So these square root functions are a lot different than the other ones. They have a restricted domain because we can't square root negatives, and they also have a restricted range because they don't go forever down always, or forever up. We'll see as we change some of the things around with this. So the domain is all the numbers greater than 0. So x has to be greater than or equal to 0, so we will say from 0 to infinity. Notice that this function is forever increasing. It's forever going up. Now, as it gets here in this end of the graph, it definitely increases less, but it's still increasing nonetheless. So our function is always increasing. Again, this is the parent function because it is the simplest version of this function. So what we're going to do on our final page here is we're going to take 4 functions that are based off of the square root function. They are square root functions, but based off that parent function, they're going to look slightly different, but the general shape should be the same. So go ahead and pause the video, plug these into your y equals, get a table of values, plot some points, and draw them. And then I'm going to share the screen with all of these done. All right, so what I did is I went ahead and put all these on there for you. So what I want to do with you right now is just talk about domain and range, okay? Domain and range all have to do with this point here, this end point. The domain is going to be, in this particular question, is going to be from 0 to infinity. And the range, well, the lowest this point ever gets is at 2, but it does continue to go higher, so it's going to be from 2 to infinity. All right, let's look on at number 2. Again, the domain is going to be very much linked to that point right there. So that point is -4. The furthest left this is going to go. The x value that is the smallest will be -4. So it's going to go from -4 to infinity. But the range is 0 to infinity, because 0 is the lowest value that this will ever get to. Going on to number 3. And we are almost done. You guys are doing great. Number 3 has to do with what point? What point am I interested in? I'm interested in that point right there. Well, the domain, the furthest left this is going to go is at +1. So from 1 to infinity will be all the x values, and the y values are how high this thing will go. Well, the highest this graph will ever get is 0. So it's going to be from -infinity to 0. And then the last one over here, since that last point is right at the origin, our domain will be from 0 all the way to infinity, and our range will be from -infinity all the way up to 0. Now keep in mind, 0 is the highest point that this will ever get. And it's going to decrease in that way. All right, so these are kind of a summary of absolute value and square root functions. So I hope this was helpful. Practice, 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 and we'll see you next time. Bye.